Welcome to the Developer Trail. Thank you, Vance and all the ThunderPlains organizers for welcoming me back once again. I've been coming for the last 5 years to ThunderPlains, and this community is absolutely wonderful. I leave this event every single year inspired and energized to build cool things, to write new things, and come away have met new people. So thanks again for welcoming me here. So let's get on to the trail. We should probably follow the on-screen instructions. Press spacebar to continue. This says we should learn about the trail or travel the trail. We should probably follow the instructions. Let's learn about the trail. We're here to take an idea on a journey from Fingertip to US West 2. It happens to be in Oregon. Now, you may think this resembles a certain game that you may have played. I don't know what you're talking about. And we're going to encounter some danger along the way, and if we're lucky, we'll make it to production unscathed. That's right, this is a talk about shipping software from fingertip to production, what goes on between the idea in our head to when it actually hits an end user, and some of the perils that we'll encounter along the way. Let's find out what those might be. So yes, now we'll travel the trail. Of course, we have to select our party, right? Instead of picking, some of you from the audience, we'll just go with you, right? You're part of this. Our feature request comes along with us. Of course, the looming deadline, which affects us in certain ways, writing software. JavaScript, because I love JavaScript. You can choose the language of your choice. Just apply that judiciously during the talk, just fill in the blank. And of course, imposter syndrome, right? I bring that along wherever I go. So yeah, Vance stole my intro, so you're going to hear it again. Hi, I'm Adam. I'm going to be your guide on the developer trail. I'm the director of security at Npm, where a small JavaScript startup that you might have heard of. I get the responsibility of securing all the wonderful downloads you do and all the packages we store in the registry. That's where you can find me online. And so to prepare you for the journey of shipping code from your mind to production, the first thing that we should talk about is threat modeling, right? This is before we've written any code. My job is to prepare you for this journey. And threat modeling is where you think about what could go wrong, you weigh the risks, and you take the appropriate action. That's the most general description I can give about threat modeling. It's the way, well, we'll get into that. Why we threat model? We threat model because we need to prioritize. We need to prioritize what we're going to fix and what threats we're going to choose to protect against. Are we protecting against basic internet attacks? Are we protecting against our employees? Are we protecting from nation-state attackers or from just government snooping or government legal requests or whatever? What are we actually protecting against? We have to think about that before we write our software. And this can help us prioritize. The other thing is that we'll never fully reach 100% secure state. We'll never reach a destination. This will come into play towards the end of the talk. So we have to prioritize. So how we threat model is important, right? We have our party here, right? On the Oregon Trail, that was our family members, and we got to watch them perish along that trail. In software, we've got assets, and how we threat model, it's kind of like you get people together, kind of like you're playing a game of D&D. Is the easiest way to do it. You get people together. Diversity of your party, is great. Have perspectives from engineering or business or development, security, architecture. Any of those perspectives are great. So gather your friends, get around a table, and then figure out what your assets are. What are the things that you actually care about? What makes the company money? Maybe it's availability. Maybe it's just a functionality of the application that we want to sustain, such as availability. Maybe it's that we want to protect user data or I don't know, something else. And you start with assets. You work your way backwards, right? So you start with the asset, and then you look at the attack surface. So what are the ways that you can actually access that? Is that an employee accessing a database? Is that a route in a web app, or is that some other other method? Can you walk in the building and touch actually touch a server? What is that attack surface? And you map that. It just starts to become this graph. So starting at the thing that's value, how can you impact that? How you can read from it if you want to protect confidentiality. How can you write to it if you want to protect integrity, or how can you just break it? You're talking about availability. And then you get to sort of like think a little bit evil. Really, you get to become that threat actor and say, like, if I was going to do something bad, and I know all of the things that are wrong with this piece of software, how would I do it? And this is where diversity comes in, right? Having a bunch of minds together, trying to figure out how you could actually impact that application. And then once you have sort of this framework mapped out, who might be attacking your application, then you look for sort of weak or missing mitigations. You look for is this control that protects, like a password protects an account, right? Do we actually ask for a password? Oh, there's no password on that. Okay, that's missing, right? Or maybe we ask for a password, but we don't have two-factor authentication, and we should. Maybe we implemented two-factor wrong, right, or something. So you look at those mitigations and how and that's where that all comes together. In the Oregon Trail, right, as on our journey in the Oregon Trail, we during the beginning, we thought about where we were going to head, right? We grabbed more wagon wheels. We grabbed a bunch of bullets because we know we had to shoot buffalo. We grabbed spare parts and things because the bandits we were gonna encounter. So we planned ahead, right? Like the point being is that you kind of plan ahead for what you're going to encounter, and you put the right mitigations in place. And one thing that I've encountered with talking to developers, being a security person, is sometimes it's hard to think evil. It's hard to know what bad things can happen to the application if you're not aware of those things. And this is one framework to do that. There's a couple different frameworks. One's called Dread. I don't mention it. Microsoft stopped using it back in 2008. Although Dread is a good set of questions to kind of prompt you to think about things, this is another way. And these are categories of different areas in which you could affect that application, such as denial of service or spoofing, tampering. Repudiation talks about identity or proving you are who you say you are, or elevation of privilege. This is just a framework, and you can dive as deep as you want into threat modeling. There's a 600-page book on threat modeling that you can go read if you want to go to sleep. But in general, if you follow this framework, you can identify ways you can impact your application in horrible ways. So, all right, that's threat modeling. That's preparing us for our journey before we've written any code. So now that we've thought about our feature, let's continue sort of on the trail. This is where we write some code. So we've designed our feature. We've thought about the security implications of our feature. How's it going to impact things? Now we're going to write some code. NPM did a survey, let's see, earlier this year, and 16,000 people responded, and 87% of you said that you worry about the security of the code that you yourself write, as opposed to 77% of you that said you worry about the open source software that you use, which is really interesting considering that your web application is 3% your code. The majority of the code that you ship to production was written by people not on your team, not by you, by somebody else in the community. Potentially, ex-employees that wrote the module that they actually published that you still use in your stack, things like that, right? So the average dependency tree for a Node app that we see from NPM audit is 6,000 modules deep. That's average, so some have very few and some have a lot. 6,000, and that's non-duplicated and things like that. But that says that you're shipping a lot of code that you didn't write to production. So it's just an interesting perspective there. And so after we've got our code written, this is where we're going to make mistakes, right? We're taking this code from NPM, from other people, and we're gluing it together. And it's that intersection of those modules and your code, it's at that point where mistakes typically are made. Modules can be used in the wrong way, right? If you use something in the wrong way, they may not have considered that for their threat model. And you could get into an insecure situation. So this is where the kind of rubber meets the road. So let's continue on. We've written some code, our own code, but we've encountered the NPM chasm, right? Which we need to cross. The perils of the Oregon Trail. We run into rivers. Here in our virtual journey, we run into the NPM chasm. If you haven't seen the diagram of like the NPM is the heaviest thing in the universe, this chasm is very deep, right? We have a giant dependency tree of modules. And I'm going to talk a little bit about the threat model of NPM, the scope of NPM a little bit here, because rerouting around this would be very costly for our journey, right? Reproducing all the code that we're going to bring in these little modules and reuse would be very time-consuming and costly. So we're not going to do that. We're going to cross this bridge as safe as it might look. So NPM, 825,000 packages as of this morning. It's a huge plethora of packages in NPM. That's about 7 million tarballs of individual versions. 10 million developers depend on NPM, and we do about 1 billion downloads a day. And so that's both wonderful and terrifying when you think about that code going to production, right? Let's talk about the NPM threat model. We talked about threat modeling. So what is the NPM threat model? What's the important thing inside of NPM? Packages. If you can manipulate packages, that's gold. So if I had to ask, what do you worry about when you use code from NPM? Right? What's something somebody worries about? If you think about packages, what's that? Backdoors, right? Malware. That's a thing. Let's talk about this is an old-timey map that I found. Malicious packages are something that people worry about, right? Those packages. There's a few different ways as we create that graph that we can impact packages, and because old-timey maps are hard to read, this is easier. We have a malicious package, and there's a few different ways. We can publish any package, right? Just anybody can publish. You can publish some garbage malware and just put it on the registry. But you still have to get somebody to install it. That's the key. Account takeover is an extremely impacting way. And of course, insider threat. One of our employees, myself, I could just go change a package and change its integrity hash, and you just get to have whatever I give you. Or you could be using an alternative CLI, like Yarn, which machine in the middle all installs. And so they give you the hash, and they give you the tarball, and they could change both, and you wouldn't know. So we have to think about these and protect against these things. And so as we look to cross the NPM chasm, we see a few relics from the past on the edge of the trail. Of course, we'd like to view them. And we see a grave marker with cross env on it. Who here knows what this is in reference to? Got one, maybe two. Okay, so this is good. This is a good story. So earlier this year, maybe last year, there was a package published to the registry. And this goes back to anybody can publish anything to the registry. Cross-env was a piece of malware that would steal environment variables. Where do we store important things? Like AWS keys in environment variables. But what's interesting is that it was a typo of a popular module, cross-env. And that's where it got its power. It's a social attack, right? So it's a typo squad attack that was mimicking as a very popular module. It didn't have a lot of impact. It did get some installs, and it was found and removed, and we found a bunch of other variants of that. This is a very common attack against on the registry, typo squatting. We've removed somewhere between 30 and 60, typo squat malware this year, and we continue to find them. So what are some of the things we're doing for that? We're bringing the security community and the development communities together. Our greatest, detection system is our community. Those 10 million developers that are using NPM, y'all that are using NPM, see something, you tell us about it. We see the pattern that it's using. We look at it across those 7 million tarballs. We find it, eradicate it. It's amazing. We've added a report a vulnerability button to all the package pages so that you can tell us faster about these things. You can just be like, yep, I use that, click, it's bad, remove it. We're looking to just kind of continue this effort, right? So that's something that we've done to, kind of guard against malware. We also have some automated threat detection, advanced as, grep. And so it works surprisingly well for finding bad patterns and things. And if you were here at ThunderPlains last year, I gave a lightning talk on knowing what your modules do when you install them. We actually have things like, we know what a module talks to when you install it. We know all the servers, all the DNS requests, all the files it reads and writes from. Fall backwards. So we're starting to do some more advanced detection beyond, say, grep. Then we're giving you NPM audit, which is going to tell you about these things if you happen to be installing a malicious module or a module with a vulnerability in it. NPM audit is going to tell you if it's somewhere in your stack. And we also do that during install. So when you do NPM install with NPM 6 or greater, we're going to tell you about vulnerabilities in your stack. And then you can run NPM audit fix because it's really annoying just updating every one of those. If we know how to fix it and what version you should update to, we should just do that for you. And so run NPM audit fix and those go away. All right, so we have one other relic from the past to talk about. So we talked about malware and in that sort of story. And now we've got another one. Who's familiar with ESLint scope? This is a little more recent. Got a little bit more news coverage. Somebody's aware. ESLint scope, well, who knows what ESLint is? Right? ESLint, popular linter, right? ESLint scope happens to be a dependency of that popular linter. And this is where, that dependency tree comes in. You're shipping code that's authored by many, many people and many, many dependencies. If you compromise one of those dependencies of a popular module, you effectively compromise the top level, right? Because you're getting that code in that chain. This particular incident was an account takeover. A user had a password that was used, that was breached. So it was a reused password that was found in a breach, and their account was taken over, and a new version of ESLint scope was published. And the only reason that this was caught was, again, by our community, because the author of the malware basically wrote some bad code. They made some assumptions about how JavaScript works, and it turns out they were wrong. So we all do that. And so they took over the account, and immediately it had 4,000 some downloads, very impacting, and it stole NPM credentials. The point being was steal some credentials, publish, oh, you're another prolific author, publish, right? Goes from there. We burned down all of the tokens in the entire registry as fast as we could in response and remove this. But we responded in some other ways too. We had a feature already in flight that would have prevented this, enforcing two-factor authentication on all your packages. So we can, if you're a popular author, you can require this on your packages, which is nice. We added breach account protection. So we can tell you if you're using a password that has been previously found in a breach. We compare that against 500 million passwords or something when you change your password or sign up and tell you, yeah, that's a crappy password, which protects you from yourself, protects the registry. We're also adding active defense for sensitive data exposure. So when you publish a module and you put your NPM token in it, or a Slack token, or AWS credentials, specifically NPM tokens, we identify, revoke, and notify you. So that's super great because you happen to as you're writing this software, as we're going along our journey, you publish an NPM module, you happen to have your token in it, it shows up on my desk, and we revoke it and email you to help you avoid falling off of that rope bridge. So now that we've used NPM audit and we've figured out which boards were loose and we made it across the chasm, a wild pull request appears out of nowhere. I mean, that's the next stage in the journey, right? We've written some code, we've merged it with, we've brought it together with a bunch of modules from the ecosystem. Now it's got to go into the pull request flow to get to production. And if you're not doing this, you should be doing the pull request workflow. And I'm going to talk about some of the things about doing pull requests and my philosophy on pull requests, because I don't think that there's quite anything that can replace a manual audit of a piece of code. But there's some things we should be aware of as we do that. First thing is that just like in the Oregon Trail, we're all in this together. When a PR gets dropped in your lap, who kind of like, when a PR gets dropped in your lap, kind of is like, ugh, I got to review that. I'm writing this thing over here that I'm going to need reviewed. Why do I got to waste time reviewing your thing? Well, it's important. That peer review like helps. You have a different perspective on the code than the person who wrote it. And the reality is that you're going to be able to help them ship this and ship it better. But you have to realize that you're now co-shipping that piece of code. You both are putting in the production. So if that goes to production and that has a bug, that's both of your faults now, or whoever's reviewing it. It's you share that responsibility. It's not just like oh yeah, it looks good to me, thumbs up, ship it. Didn't really look at it, skimmed it, variable names look good, hate how you use brackets. Like just no. We can do better. We can do better than looks good to me. We can communicate the perspective that we looked at it. I looked at it for security things. Well, that may be implied because of my job role, or a designer is going to look at it for design elements. But communicate that as you do your review. What did you actually do? And that will also help them understand what you did. Looking at it in the future. And they're powerful. Pull requests are also powerful because they remind us to do something. And this is an important piece of building new habits or writing a better code. And this whole journey is about discipline, right? Like software development is about discipline, and it's about improving things as we go. And to build new habits, we need reminders, right? This is how we build habits: reminders, routine, and reward. Reminders, initiate the trigger to do something. So if that pull request comes in, now you're like, okay, I remember that guy at the conference said that I was not supposed to just give this a thumbs up. I better put some effort into it. When you get your next pull request, you're going to remember that. You're going to be like, all right, I need to put some effort into this. But it's only effective if you actually do the routine. The alarm goes off. If we just hit snooze, we're not getting to the point of being a morning person, right? Like we're just delaying that. So we have to do the behavior itself. And then from there, we get the reward. We get the reward of shipping more quality software, whether that's security, stability, arguably the same thing. It's better. So let's talk about my sort of flow for looking at pull requests. Checklists, whatever you do, if you follow this or you follow something else, checklists are another extremely important piece of shipping quality software. If you want to argue with me, look at the airplane or the airline industry. Pre-flight checks, right? They have them for a reason, because they help things be safe. When you're annoyed that the tray table is broken, so we can't take off, right? Like they make sure the little things are taken care of. Surgeons also didn't want to adopt checklists, but accidental death rates when they adopted them dropped by like 50%. So like checklists kind of are important, and they help you, remind you to sort of like check these things. So whichever perspective you take, on checklists, use one. This is mine. I look at what sources, inputs and sinks, outputs were added. All right, where are you getting data? Where are you sending it to? All right, and what is it flowing through? What new dependencies were added? Did you bring in one dependency, but that one dependency has like 1,000 dependencies? What does that look like, right? How did that change the threat model? Did it bring in stuff that we just don't need? Are those things vulnerable? And you can automate some of those with bots that put little things in your pull requests. That automation is great. You shouldn't have to do that as a human. Automate everything away that you possibly can if it's got a good quality signal. What new technologies were added, right? Did you add some database, SQL? All All right, you got to worry about SQL injection, right? You're reading from the file system, you got to worry about file system style attacks. So what inputs syncs, what technology it flows through, what behaviors were introduced or changed. Did you change something about how you log some piece of data? Are you now logging sensitive data? Or do you change something with the login process? Maybe there's a login bypass now. But that's something to think about. And of course, tests, it better have tests. Those tests better pass. If it doesn't have tests, it's just a nope, not nope. Now, that's the other thing is test coverage. You can have 100% test coverage and still have crappy software. So appropriate tests also, did you regress in test coverage? 100%, you might not have 100% test coverage, but did it regress? You can automate these things in pull requests as part of your sort of life cycle. The other thing, from the Oregon Trail, also as a good reminder, you shoot a 600-pound buffalo and you can only carry 100 pounds of meat back. Same thing is, the PR submitted, the team was only able to review 200 lines of code. Your effectiveness drops off after 500 lines of code per hour, kind of a thing. Like if you review anything above that, your ability to find defects drops off significantly. There's been studies done about this. There's a little tiny link at the bottom where you can go read more. Small pull requests are better. You're going to find more defects when you review them. Also, don't code review for more than a half hour or an hour. Back when I was doing a lot of code review at Symantec about 10, 13 years ago, it was 1,000 lines of code for 8 hours. That was kind of the I don't know, measure. And it's just, you can't find anything after an hour. Like your brain is just like, you're just like, yeah, whatever, it looks good. Like, you can't keep state. You can't keep all that state. That's the other thing, writing clear, not clever code. Nested ternaries, don't do it. Like, nobody can follow state in that. The spread operator, do you really know what that does when you're reviewing it? Are you really tracking that state? No, it looks like, it's like pseudocode, ... Yeah, it does something. Can't do the spread operator. Okay. So that's my spiel about pull request reviews and things that can help you. And now, off in the distance, you hear something. You hear an old man yelling at a cloud. I actually kind of feel like, I was thinking about this last night, I kind of feel like Abe Simpson. I'm like the old man yelling at the cloud. We used to have managed servers. We actually had physical servers. And we dealt with IP tables and password management and full disk encryption and backups. And cloud was supposed to make all this great, but it really hasn't. All these secure environment variables and open S3 buckets and insecure security groups, like, it's just more of the same. It's just delegated someplace else. This is me yelling at the cloud. And so congratulations, you've made it to production. Effectively, you've shipped to production. There's many ways we're going to ship to production. You're going to put it on a EC2 instance, or you're going to ship a Lambda, or you're going to put the static assets in an S3 bucket. And the thing there is that, and the whole kind of point about this journey is that the resource you ride with, helped you on your journey. But it's far from over. It's a journey, not a destination, right? The whole point of this talk is that we never really reach the end, and you're always going to be improving. It's like the Penrose staircase, the optical illusion of always going up. You're always taking a step up, taking a step forward, forever and ever and ever. So then, as a defender, you'll never fully secure your application. It's not a 100% thing. You'll never reach that. So kind of why bother, right? Like, well, because we fight for the user, right? Like, just like they took the Oregon Trail west for a better life, right? Better future. We fight for the user. We improve our discipline, for ourselves and to make things better, because like that's the right thing to do. I had something else in here. My notes are failing me. But really, it's about discipline. It's about improving your discipline. It's about that journey, ever increasing improvement on your skills and discipline. I'm just trying to ratchet that up every time you do that, from your inside your head to your fingertips, to publishing modules, to doing pull request reviews. Every time you do that, you should be trying to ramp up and improve. Quick shout out to the original Oregon Trail developers who wrote on HP 2100 platform. It was all text, right? You had to type bang really fast or pow when you hunted. I actually loved it. There were teachers from Minnesota, so they wrote software to educate, and I think that's absolutely awesome. Also, it took about 5 months to do the actual wagon journey, on the Oregon Trail. Imagine taking that long to ship, pull requests. Ridiculous. So congratulations, you've made it to the end of the talk. We do have time for questions. Oh, we're hiring. Shameless plug. That's it. I'm done. Any questions? Are you sleeping? Anyone sleeping? No questions.
So as far as NPM goes, what do you think, what's your biggest concern, what's your biggest security concern going forward, right? What's your most anxious point there?
Protecting accounts. Account compromise is the biggest impact to the registry. If an employee account is compromised, right, that would be impacting as well. But giving you the tools to protect the packages that you publish, so that somebody can't just publish a new version and have that big impact like they did with the ESLint scope. That's probably my biggest worry. I play cyber janitor and clean up malware all the time, with people publishing random garbage proof of concepts to the registry, and we try to just keep that out of there, but they have little impact. They affect a few people when you just randomly type npm install something. If you're not sure, don't just type it and hope. Go to the npm site and look, or npm view, or
How do you balance between security and productivity without going too far and generating problems?
So that's part of the threat modeling process, right? So you balance that based on the risks the organization is willing to take. To become more secure takes more time, more effort, right? And so, each organization's different. That is a challenge. We rely on, I just did this last week, we rely on 7,000 modules from the ecosystem across the organization. Just calculated that a couple days ago. We rely on modules that are in the open source ecosystem that are from ex-employees, right? So we have to keep an eye on those, right? We watch those carefully. Did they get published? Also, package we update very intentfully. We don't just be like, yeah, just update some stuff. Lock files are great, right? Because they keep a state. I like services like Greenkeeper because keeping things up to date also means you're getting in those security patches. But keeping up to date too fast could be bringing in things that are vulnerable, or not vulnerable, but malicious maybe. So, it's all about the process and putting those gates in. A pull request being a great gate at that moment to apply security. We don't like to slow down pull requests, so security will often, that process happens, and high-risk pull requests will get, reviewed with more urgency than some, documentation update, or something. We also have, do quarterly audits and reviews of important things that have changed. External reviews, we need to find a new external pen testing vendor since NPM bought my company, which used to do them. So, yeah. We have 5 minutes left. Any questions? In the back.
Do you think that passwords that be completely replaced with key insertion?
probably a good thing if they were. We're bad as humans at selecting good passwords. Don't select your own passwords, put them in password safe. I mean, the middle ground there is like a password safe where you just, keys are great, but you still have to manage them, just like passwords. So if it's a hardware fob, you lose it, right? So usually that plus a two-factor would be good, which we have, so you can use. But yeah, passwords are horrible. Passwords get us in a lot of trouble. People are lazy.
When you do have a large PR, how do you make it, like you break it up and give it to people, or how do you be accurate with that large PR?
You have to take your time. So take the appropriate time. You don't just be like, yep, it's good. I spent my hour. Take the time that's appropriate for it. If you look at it and you're like, yeah, this was a bunch of boilerplate that doesn't change behavior, okay. But like look at it and take the appropriate amount of time, or look at the part that you are appropriately skilled for to review, and then pass that along. Put those notes, document that. Say, I looked at this piece from this perspective. You need to look at this piece and break that up. More eyes are going to uncover bugs.
So clearly, the fewer one-line packages there are on NPM, the less opportunities there are to compromise the threat. So do you think a lot like NPM audit, there would ever be that NPM could ever take action with a similar sort of tool to suggest that developers could remove very light dependencies?
That sounds like a great feature. Yeah. Sometimes those one-liners are good because you can mess those things up too. That regular expression that you're like, why is that one package is just one regex, right? Because they took a lot of time and attention to think about that. We don't want to write it again and again. So sometimes they have their purpose. I don't necessarily think big dependency trees are bad, but there be dragons sometimes.
You mentioned other alternatives, like CLI.
Mm-hmm.
What are your thoughts on that? Just like their security.
It adds to the attack surface. So specifically Yarn adds to your attack surface by you not only worry about our insider threat, you worry about their insider threat, which is probably fine. I mean, like it's sponsored by Facebook, and the reality is the situation that I explained can't currently happen because we control the endpoint. So when we switch to Cloudflare, you can't redirect from Cloudflare to Cloudflare, and so we broke Yarn. And we could have left it that way, but we were nice and we took over their endpoint, so Yarn would still continue to work. So we effectively controlled both, but just so that wouldn't break for y'all that are using Yarn. But should they take that domain back and move it or do something, like they effectively have that. So it increases your surface area. I think the one nice thing is that another CLI is competition. Competition drives innovation, and it drove NPM 5 to be faster. And I don't know. That's what I got. And I think, we got one more. We got 2 minutes. Cool.
What about cross-site can you speak a little bit about the left pad issue?
So the other one was left pad, and I left it out just in the manner of time. So left pad situation happened where it used to be that you could just unpublish whatever you published, right? So the left pad was a popular module that was used, and the author removed it from the registry. Well, that broke a lot of people's software, and so that's an availability concern, right? So we addressed that by making it so you can't just remove software from the registry. I think it's 24 hours now. It may be 72 hours. When you publish something, you can remove it within that window. If you accidentally publish something, you published it, you realize that was an internal, I shouldn't have published it. You can take it down, and beyond that, you can contact support, and support will review it. We basically have a policy. We solved it with that and with policy. So now you effectively can't remove it, but you can contact support and say, hey, I'd like this module taken down, and we're going to look at that and say, yeah, it's used by 2,000 other packages and gets 500,000 downloads a day. No. You know, that's just the way it's going to be. So that's how that changed. And you know, those as we saw with gravestones, right? We had these gravestones are relics from the past, but we learn from them. As the community matures and as we see these, you know, have these events happen, we learn from them and we make things better. So that's what I have. Time's up. So thank you.